And in simplex method we have also a term known as dual. So whatever the original problem what we have written is known as primal. That means when the original problem is known as primal, there is an associated problem with the original problem or with the primal, which we call that as dual. For example, when we are saying maximization of profits, if that is the primal or that is the original problem, then minimizing the cost is the dual of that problem. Or minimizing the cost is the primal problem, then maximizing the sales is the dual problem. Or what we can say is for every problem we have a dual problem. The original problem is known as primal, and the other problem which is associated with the primal or original is known as dual. If primal problem is maximization problem, the dual problem will be minimization problem. Or if the primal problem is minimization problem, the dual problem will be maximization problem.
Now we will do a problem on minimization objective function of formulation of LPP. So earlier we had done a problem on maximization. Now we will see how a minimization problem looks like. So here in this problem, a group of passengers wanted to hire chartered planes for those tourists. So those tourists want 2 types of seats in the aeroplane. So what the group needs is 140 executive class seats, and 350 economy seats, economy class seats. So the airliner offers 2 types of aeroplanes for chartered purposes. So in that case, this group of tourists are putting some conditions stating that the models which they would like to hire is P371 model, and another model is R268. model they have to hire. So at least 2 numbers of P371 and 3 numbers of R268 have to be provided by the airliner. So in that case, that is a constraint put on the airliner, and the number of seats are also provided in the problem, where this P371 has each P371 has 15 executive seats and 40 economy seats. So in that event, we have to minimum they have to be hired, and the R268 has 30 executive seats and 50 economy seats. So all these things have to be taken into consideration, and the aircraft company airliners should be able to arrange sufficient number of P371 as well as R268 such that the total cost of hiring should be minimum. So, however, the rent charged by the aircraft is rupees 3 lakhs for the trip for P371 and for R268 they charge rupees 5 lakhs per trip. So we have to formulate a model for this, so with taking all these constraints into consideration. But our purpose here is to minimize the overall cost without compromising on the number of seats both on economic class as well as executive class. So we have to formulate a linear programming problem. So now we'll start. So here the constraint is 140 executive class seats should be there and 350 economic class seats are there, should be there. And at the same time minimum of 2 aeroplanes must be arranged of model 371, P371 and 3 of at least model 268. And the cost should be minimized. So here what we will do is solution will let us say we hire x1 number of P371 and x2 number of or number of P371 and R 268 to be hired by the group of tourists. Now we will write the objective function. Now we will write the objective function. Based on the problem situation, here we are actually supposed to minimize the total cost. We should be able to accommodate all the passengers both in executive class and economic class, and at the same time we should hire minimum number of flights or aircraft such that the total cost of hiring should be minimum. So the objective function is minimize z is equal to 3x1, where 3 is the 3 lakhs hiring charges for P371 and 5 x2, so hiring charges. Right? So what actually it indicates is x1 is the number of planes of P371 and x2 is the number of x2 is the number of R268 flights where they charge 5 lakhs for each of them. Then there are certain restrictions. What are those restrictions? That is subject to constraints. Subject to constraints. What is that? Each P71 will have 15 seats of executive class. That means x1 is the number into 15 plus, and 30 seats are available in R268 where x2 is the number of executive class seats in R268, and which should be minimum of 140. That means this constant is executive class seats constant. That means minimum those seats. Then when it comes to economy class seats, P371 will have, or it has 40 seats for each plane. X1 is the number of aircraft that are hired, and for R268 there are 50 economy class seats are there and x2 is the number of R268 passengers, and the total should be, the minimum total should be greater than 350. That is economy class seats constraint. And other than this, there is also other constraint. What is that? Earlier they have mentioned P361 should be hired minimum 2. That means minimum, that is greater than. There can be more, but minimum should be, right, number of aircrafts to be provided by airliners. And similarly, when it comes to now we'll write for x2. There is a constraint that the same thing to be provided. This is same thing, that x2 is, this is R268 planes, this is P371 planes. So this is a constant, and after this, as usual, it is a standard procedure where we need to write where x1 and x2 are non-negativity restrictions. Right? So what it indicates is x1 and x2 cannot be negative numbers, or we can write like this: x1 comma x2 should be greater than or equal to 0. What it indicates is, and x1 and x2, either planes can be 0 or number of planes. There are no negative number for x1 and x2. That is the reason we call that as non-negativity restriction. That means under any circumstances, either x1 and x2 should be 0 or some positive number, and under any circumstances it can never be negative number. This is the way we formulate a problem for minimization.